On this slide, we talk about traditional definitions of sine and cosine. So we start with the right angle triangle, which is already drawn, and now I have marked an angle theta in rust color. Then I will mark an angle phi in green color. So now let us talk about the sides. So we have this side is called opposite to angle theta, but it lies right next to angle phi, so it is also called adjacent to angle phi. Now this side, so this side is opposite to angle phi and adjacent to angle theta. So first I am writing adjacent to angle theta. As you can see, it is right next to angle theta, but it is opposite to angle phi. So write opposite to phi. So hypotenuse we just call the hypotenuse, and we will denote hypotenuse by h. So this side we call A and this side we call B, and hypotenuse we will call h. So the traditional definition is sine theta side opposite to angle theta. So it is side opposite to angle theta divided by hypotenuse. So opposite to angle theta we have denoted by A, so we say A, and hypotenuse is denoted by h, so we write A by h. Definition of cos theta is side adjacent to theta. So side adjacent, I am writing AD for adjacent, adjacent to theta divided by hypotenuse. What is adjacent to theta? It is B, and hypotenuse is h. What about sine phi? Sine phi is again definition opposite to angle phi divided by hypotenuse. So sine phi is opposite to angle phi is B, and hypotenuse is h. Cos phi is adjacent, side adjacent to angle phi divided by hypotenuse. Adjacent to phi is A divided by hypotenuse, which is h. Note that theta plus phi is pi by 2. Yeah, because it is a right angled triangle. All the angles sum up to 180 degrees or pi, and one angle is pi by 2, therefore theta plus phi is pi by 2. Notice that cos phi and sin theta are same, they are A over h. Yeah, sin theta is equal to cos phi because both of them are A over h. Now you can, from this equation theta plus phi equals to pi by 2, you can write phi is pi by 2 minus theta, and that you substitute here, you get sin theta is equal to cos of pi by 2 minus theta. Similarly, you see B by h and B by h are same. So B by h here is cos theta, here it is sin phi. So both are equal because both of them are equal to B divided by h. So again we write phi equals to pi by 2 minus theta. So cos theta is equal to sin pi by 2 minus theta, and that is what I am going to write. sine of pi by 2 minus theta. So you know the two formula now. Cos theta is sine pi by 2 minus theta, and sine theta is cos pi by 2 minus theta. So this is a good way to remember sine theta and cos theta, and sine phi and cos phi. So we want to compare this definition to what we gave in the unit circle. So unit circle is nothing but rescaling. So you draw the same triangle again, you have a right angled triangle, but the only difference is now you divide everything by hypotenuse. Yeah, so the angles remain the same as theta and phi, but you have made the triangle smaller or larger depending upon scaling by dividing by h. So you divide all sides by h. You get b by h here and a by h here. Again you see the definition remains the same. Sine theta will still be a by h, because now opposite to theta is a by h, but hypotenuse is always 1. So again sine theta and cos theta, sine phi and cos phi, all these definitions remain unchanged. But now this is comparable to our previous definition, that is inscribing in a unit circle. So the only difference between this and the previous definition is that this definition is rescaled to 1. Hypotenuse is scaled to 1. Now we are going to talk about two important triangles which show up a lot in problems. In fact, these are the only two triangles which show up, and it is important that you remember them by heart. So the first triangle is that theta and phi are both 45 degrees or pi by 4. So this angle is pi by 4 and the other angle is pi by 4. So hypotenuse we will always scale to 1. So here you remember base is 1 by root 2 and height is 1 by root 2. Yeah. So again you have cos theta is cos pi by 4, which will be 1 by root 2, and sine pi by 4 will also be 1 by root 2. Okay, from the definition. And since we had made hypotenuse 1, you just have to see sides opposite to the angles. So very easy to, yes, because of rescaling, sine theta will just be opposite to angle theta, and hypotenuse is 1, so you divide by 1, you still get side opposite to angle theta. So now we take angle theta as pi by 3 and angle phi as pi by 6. So now we will have these two sides. Yeah, for opposite to pi by 3 is root 3 by 2, opposite to pi by 6 is 1 by 2. So what is sine pi by 3? It is opposite to angle pi by 3, that is root 3 by 2. What is cos pi by 3? This is adjacent to pi by 3, which is 1 by 2. What is sine pi by 6? It is opposite to angle sine pi by 6 is opposite to angle pi by 6, which is 1 by 2. What is cos pi by 6? It is adjacent to angle pi by 6. So this is root 3 by 2. So notice the behavior. Yeah. So cos pi by 3 and sine pi by 6 are same. And we have already talked about that cos 0 is 1 and sine 0 is 0. So I want to first draw the graph of sine. You should, my graph is not very accurate. You should also see the graph in Wikipedia. So for 0 it is 0. This is how the sine curve will look like. Something like this. And the second graph we will draw the cosine part. So first let us see the sine part. So for 0 it is equal to 0. It is 1 at pi by 2. It becomes 0 again at pi. This should be pi here, not 2 pi, pi. I will correct this later. So cosine will look like this. At 0 it is 1, at pi by 2 it is 0, and so on. So notice that sine and cosine are moving in opposite directions. So you have 0 here, pi by 2 here. So this I said before is just pi. So this is pi by 2 here, cos pi by 2 is 0. Then cos pi is here, cos pi is minus 1 and sin pi is 0. And then you come back to cosine of 2 pi, which is 1. At cos 3 pi by 2 it will be 0, and sin 3 pi by 2 right here will be 3 pi by 2. So sin 3 pi by 2 will be 1 and it will be 0 at 2 pi. So now I have corrected. Sin is 0 at 0, pi by 2 it is 1, and then pi it is again 0.